students. Today we will discuss about the relations topic wise and some important questions. Due to COVID situation, there are some changes in the questions pattern. So you have to focus on the concept of every chapter and you have to solve max to max MCQ type questions. Okay, this concept is for all any type of board exam and for any type of competitive exams. Okay, the first topic is relation. What is relations? A relation which is denoted by basically R from the set A to the set B is defined as R is a subset of A cross B. What is A cross B? How can we find out? If A is given, suppose 1, 2, 3 any set and B is given any set AB, then we can find out A cross B this way. 1 comma A. First you have to write the elements of A. After that you have to write that the element of B. 1 comma A. Now again we are taking 1 with the other element of B as 1 comma B. Now we have to proceed to the 2 comma A, 2 comma B. In the similar way 3 comma A and 3 comma B. 3 comma A and 3 comma B. So this way we can find out the elements of A cross B. So this is the element of A cross B. Here R is the subset of A cross B, then R is called relation. Now we will show you some examples of some relation that it can give you some clear concept about relation. Suppose I am taking one relation R1 whose elements are 1 comma B and 2 comma A. So you can see here 1 comma B which is lies in A cross B and 2 comma A which is also lies in 2 comma A cross B. So that's why you can write R1 is a subset of A cross B. So then R is a relation from A to B. Now if I write a relation R2 which is 1 comma C, comma 2 comma A, comma 3 comma B, and you can see here 1 comma C which is not lies in A cross B. So that's why not lies between, not belongs to A cross B. That means R2 is not a subset of A cross B. So R2 is not a relation from A to B. So these are the idea about relations. Now another topic is we are trying to find out any domain of any relations. Any relation, suppose if R is a relation 1 comma A, 2 comma B and 3 comma A. These are the elements of R. Then domain is the first element of each set. See here 1, 2, 3. First elements 1, 2, 3 are the domain and the A, B, C which is the range of R. So range of R is A, B, C and the domain of R is 1, 2, 3. These are called the roster method. If I write this in the tabular method, so you can see here, suppose x comma y and elements of R and x belongs to A and suppose y belongs to B. So the domain of R is all the elements of X and the range of R all the elements of B. That means all the value of possible value of Y. So all the possible value of X are here domain and all the possible value of Y are here range. Now we will proceed to the next topic which is the inverse relation. Suppose if R is a relation from A to B, then R inverse, this is the symbol of R inverse, is also a relation from B to A. If we proceed from A to B a relations, this is A set and this is B set, suppose this is R relation, then R inverse the reverse one. That means you have to proceed from B to A. For the R, domain is A and the B is range. For R inverse, you can see the domain is B and A is range. So here R inverse is a relation. This is also a relation which is from B to A. If I give you an example, suppose R is 1 comma A, 1 comma B, 2 comma A, 2 comma B. So the R inverse must be its opposite. That means the domain of R will be the code range of R inverse and the range of R will be the domain of R inverse. So 1 comma A becomes A comma 1, B comma 1, A comma 2, B comma 2. So, and this is a roster method. I will show you by the tabular method. You can see suppose R is equals to x comma y where x belongs to A and y belongs to B, then R inverse, which is must be y comma x. The range will be domain and domain will be range. Then this is the R inverse. Now we will discuss some examples which are very important questions. This is a very important questions. The first question is total number of relation from the set A to the set B is. So you can see here the A set containing 3 elements and B set containing 2 elements. So we can use here one formula. So the total relation here relations equals to, we have to remember this formula. It's a very technical formula. 2 to the power the elements of A, that means 3, into the elements of B, that means 2. So the answer will be 2 to the power 6. That means the first one is correct. Okay, I think you get my point. So this is the formula. If any set, suppose any set, here also a similar type question. Total number of relation that can be defined on the set A, where the A containing 4 elements, 1, 2, 3, 4. You mean here you think there are no 2 sets, but here a relation between A to A. So A to A means A containing also 4 elements. A to A means the other set which is also A, which is also containing 4 elements. So the answer will be must be 2 to the power the elements of A into the elements of B. Here B also A. So 4. So the answer will be 2 to the power 16. I think you get my point. These are all important questions. Okay, thank you friends. And the next class we will discuss important questions from the relation, and we will discuss reflexive, symmetric and transitive relations. Thank you.